All right. So as we talked about earlier, arguments are comprised of statements, right? They're groups of statements that have been brought into a particular relationship with one another. In categorical logic, the statements that we're going to use to construct our argument are called categorical statements, okay? Categorical statements are statements about things that can be categorized, things that have some feature that allow them to be brought into a group or a class of other things that are like it. So for example, you look at these two statements up here, there's things being talked about that we can categorize and distinguish from other things. Successful logic students wear ballerina outfits. There's no such thing as a successful logic student who wears a ballerina outfit. Okay, so we've got successful logic students. That's a group or a category of things that's distinct from unsuccessful logic students, and it's distinct from non-logic students. And we've got this other category related to ballerina outfits. What's the category there? Is it ballerina outfits? Is it people who wear ballerina outfits? Students who wear ballerina outfits? Okay, what's the category? Similarly, what are the categories of things here, or the things that we could categorize that are being mentioned in these two sentences? Not every pit bull is dangerous. There are quite a few pit bulls that are dangerous. So again, pit bulls, we can categorize that. That's a distinct grouping of dog. Similarly, dangerous, not really a category of things, but we could have dangerous things or dangerous animals. Okay. Now, to use all of the features of Aristotle's system of thinking, categorical logic, we're going to have to use a particular kind of categorical statement to construct our arguments. And that kind of statement is called a standard form categorical statement. So your garden variety categorical statement, like you're seeing here on your screen right here, is not going to be sufficient for our purposes. We're not going to be able to apply all the principles of Aristotelian categorical logic. Instead, what we're going to do is we're going to take whatever statements it is that we're looking at that are not in standard form, and we're going to translate those statements into standard form. What is standard form, you ask? There's 4 and only 4 standard form categorical statements. One of them is what we would call an A statement, and it takes this form. All blank are blank. Now, what fits in these blanks here are countable things that can be categorized. Okay, so all dogs are canines. I can count and categorize dogs. I can count and categorize canines. Okay. Another form of a standard form categorical statement is the E statement. No blank or blank. No dogs or cats. I can count dogs. I can count cats. I statement. Some blank or blank. Some dogs are brown animals. And finally, the O statement. Some blank are not blank. Some dogs are not brown animals. Okay? So we're going to use just these 4 forms, kind of like templates for a statement, to apply the different principles of categorical logic to construct valid arguments and to test other arguments for validity. But we're going to have to make sure, and this is going to be the challenge, that we're translating the statements that we're working with correctly. Okay, so guess who's going to be doing that in the next few seconds? You. All right, so now as you do this, I want you to look at these 4 statements, and I want you to see how you would translate each one into one of these 4 forms. That means you're going to have to interpret, are these statements talking about every single pit bull or just some of them? Or is this statement telling me that this group of people belongs with, or this one category belongs with this other category, or is excluded from this other category? And what exactly are these categories? Now, here's the thing you want to take note of. One of the things, the most common mistakes, or one of the things that people struggle with most commonly for these first few weeks is with whatever the term is. That's what we're going to call what goes in these blanks. Whatever the term is that goes on the right-hand side of are or are not has to be countable. And that's going to drive some folks nuts. They're like, oh, I didn't have it countable again. I had, wear ballerina outfits, and I can't count wear ballerina outfits. So I've got to figure out a way to translate wear ballerina outfits into something that's countable so that I can figure out how to fit it into one of these 4 forms. Okay, so this is what you're going to do. You're going to pause your video, and you're going to try to translate each one of these 4 into one of these 4 forms, and then you're going to start your video so we can check your work. All right, let's see how you did. Okay, successful logic students wear ballerina outfits. That sounds to me like somebody's making a sort of broad claim about every single successful logic student. No matter who they are, if they're successful, they are people who wear ballerina outfits, okay? So we might translate that as an A statement. All successful logic students are students or people who wear ballerina outfits. You could even do something really fancy and awkward like ballerina outfit wearers or something like that, because that's countable as well. There's no such thing as a successful logic student who wears a ballerina outfit. Ooh, that's telling me that all of those successful logic students, they're excluded from that category of things called people who wear ballerina outfits. And when something is being excluded, we're going to use a statement like this. No successful logic students are students who wear ballerina outfits. Not every pit bull is dangerous? Okay, so some pit bulls are not dangerous animals. Did you do some pit bulls are not dangerous? Dangerous isn't countable, right? So we want to make sure that we have dangerous animals, dangerous things, something that's countable. And finally, some pit bulls are dangerous animals, okay? So if there are quite a few, that means there's some number of them. So many, some, these things we can use some to account for any number, one or greater, that's less than all. All right.